All right, in this video I'm going to go over the difference of perfect squares, which is one of the easiest factoring lessons that you'll ever have. You just have to remember that you have to meet all the criteria. It has to be a difference. What is a difference? It's subtraction. So, subtraction check. We got a subtraction problem, okay? Of perfect squares. Now, both of these have to be perfect squares. 16 perfect square? Yes. X? Yes. X squared is a perfect square. 144? Yes, that is a perfect square. It's all right that it's negative. Don't freak out like, wait a minute, I thought square roots of a negative were imaginary numbers. In this case, we're just looking at the 144 there. So, what do I have this written down here for? Somebody realized that the difference of perfect squares factored out is just a plus b times a minus b quantities. But we got to make sure we use the right a and the right b. So a squared is 16x squared, right? Take the square root of both sides, like we're solving for, because we're solving for a, right? So a is square root of 16 is 4, square root of x squared is x. B squared is 144, square root of both sides. So we're just left with b. Square root of 144 is 12. And we just take these numbers and put them into this formula. A, which is 4x in this case, plus b, quantity, times the quantity. Those parentheses are very important. 4x minus 12, a minus b. And we're done. That's your answer. Well, that was fast. Why does that work? Well, when we check our answer, we're going to find out why. Because when you FOIL this out, you're going to end up with a squared minus b squared. So just in checking our answer, we're going to verify this. So what these are called, these two binomials together, just rewriting it over here, these are called conjugates of each other, which means something different in biology. But I digress. It means one has the positive in the middle and one has the negative in the middle. You know, everything's the same except for those signs in the middle there. Now, what happens when we FOIL that out? Distributive property. 4x times 4x, 16x squared. 4x times negative 12. Oh, man. Negative 48? Yes. I'm just going to check my math real quick. Yeah, 12 times 4 is 48. Okay, now the other one, distributive property, 12 times 4x, positive 48. Ugh, can't write today. Positive 48x minus 12 times negative 12 is negative 144. Combine like terms. Negative 48 plus 48 is 0, right? 0x, anything times 0 is just going to be 0, right? So those cancel each other out, and you're just left with 16x squared minus 144. exactly what we started with, so we factored it out right. Because that sign changed, those terms in the middle, when we use the distributive property, will get canceled out every time, so long as all the other conditions are met. That's why the answer is just a plus b times its conjugate. All right. Try one more example. This is so easy, we only need to do one more example. Subtraction, perfect squares, all sorts of things need to be met. 81 y to the 6 minus 9. Well, we have the difference part of it checked. Are these perfect squares? Well, 81 is a perfect square, right? That's 9, right? Square root of y to the 6th, is that a perfect square? Of course. 6 itself is not a perfect square. Y to the 6th, since 6 is an exponent and it's an even number, yeah, definitely perfect square. It's just divided by 2 in this case because, well, if you want to get down to it, another way to write a square root is to write it to the 1/2 power. And when you're taking the power of a power, you multiply them together. So 6 times 1 is 6, divided by 2 is 3. Just in case you missed my lesson on radicals. So now, is 9 a perfect square? Absolutely. Square root of 9 is 3. Don't forget the conjugate, and we're done. Boom.